Hello, today we're going to be looking at dimensional analysis and understand the concept of how we cross out those labels as we try to go from one unit to another, and then we'll be able to use this and apply this to stoichiometry and chemistry. So to start with, if I look at any kind of recipe, I like pizza, so here's a hamburger pizza, and if I look at this recipe, it tells me what ingredients I have in the different amounts. Now, if I wanted to know how many this recipe would make, I could look right up here and it says that it serves 2. So that's great. I know that this recipe will make me 2 different hamburger pizzas. But what if I had a handful of friends coming over? What if I needed to make at least 6 of them? What would I do in order to adjust for that? Well, hopefully you're just thinking you would just double or triple the recipe to make whatever you would need. In the case of making 6, we would triple the recipe. So instead of serving 2, you would serve 6, and then we just multiply each of these by 3 as well. It's that same kind of concept with crossing out labels and multiplying that we're going to be looking at with our dimensional analysis. Now with this example here, it says how would you figure out the number of seconds that are in 72 minutes? You're probably in your head right now already thinking I would take 72 times 60 and then I would have my number of seconds. And that would be correct. But we want to look at how you are actually getting that mathematically, what's going on. So we're going to write that out. If we have 72 minutes to start with, you said that you're going to multiply it by 60. And the reason that you are multiplying it by 60 is because there are 60 seconds in 1 minute. So you can see what happens here when we multiply it by this ratio of 60 seconds per 1 minute, that we have the units of minutes on the top, and then we have the units of minutes on the bottom here. So those units will actually cancel themselves out, and then we're left just with our seconds, which is what the question is asking for. So if I pull my calculator over here, and I go 72 times 60, I'm going to get my final answer of 4,320 seconds. Okay, now let's say I'm going to look at this next part where it says how many seconds would be in 72 hours. Well, there I'm going to be starting with my 72 hours, and I have to think about what units to cross out. So I might not know how many seconds are in an hour, but there are smaller units in between hours and seconds that I can use. So I know how many minutes are in hours, so I can write that ratio out here. So I'm going to write the 1 hour on the bottom because I want my units on the top and the bottom to cancel out. And then I'm going to write my 60 minutes up here. And now I'm in units of minutes, and I know how many seconds are in 1 minute. So I write 60 seconds over 1 minute. And I can cross out my units. Now you might be thinking to yourself, I don't need to write this all out. I can just do this in my head, and that's fine. But once we get into chemistry related things and using molar masses and using mole ratios, you want to make sure that you do know how to do this dimensional analysis process with crossing out the labels. So if I pull my calculator back over and we go 72 times 60 times 60 again, so I'm just multiplying everything across the top, and really then I would do equals and then divide it by everything that's on the bottom. In this case, since I'm dividing everything by 1, it doesn't change anything. So then my final answer is going to be 259,200 seconds. And you could write that in scientific notation as well. Why don't you go ahead and pause the video and try to solve this, writing out the whole equation for both days and for years. Now, as you were thinking of solving this, you can't just go right from days to seconds without doing steps in between. So you want to be thinking through how many minutes or how many hours are in days, and then from there you convert it down to seconds. So if you tried to get the answer, hopefully this is what your work looked like, and you got the same answer. And then here would be your answer for starting with 72 hours and how many seconds are in that. Okay, so here we got another problem where you're crossing different units as you go through it. So as we read this, we want to make sure that we're underlining the key components of what the different units are or the different pieces of information that we're going to need. So it says, pretend that throughout the grades at Oostburg schools, and that's going to be K through 12. So I'm going to underline that because that's a total of 13 grades. There are 4 classes per grade. Okay, so that's going to be an important ratio to use. Each class consists of 25 students. Okay, so that's also good to know. There's 25 students per class. And each student has their own desk. Assuming that desks are only in the classroom, how many student desks are in the schools? Okay, so in order to solve a problem like this, you want to think of what you have to start with and then where you're going. So our ending question is how many student desks are in the overall school. So there's a variety of places we could start here and what we want to begin with. So I'm going to just start here on the top, and I'm going to start with our 13 grades. And using units is extremely important, making sure you write them down. Now if I start with 13 grades, I need to break that down into a smaller unit. I need to convert it into something else that's going to eventually get me to this number of student desks. So I have 13 grades. I keep on reading and look back and I see that it's at 4 classes per grade. So I can write that ratio. Now I want to write the grade on the bottom so that the units cross out. So now that the units cross out, I can actually X them out. And on the top there's going to be 4 classes. So now as I keep on looking, I have to find some other kind of ratio that I can cross classes out. So if I look back into the word problem, it says each class consists of 25 students. So there's my ratio right there. 1 class and then 25 students. So cross my units out, and now I'm left with students, and I'm not quite there. It says how many student desks are in the schools. So then as I kept reading, it says assuming that desks are only in the classroom and also that each student has their own desk. So this is actually going to be a 1-to-1 ratio. There's going to be 1 desk per every 1 student. So that last step helps me to cross out my last unit. So if I go ahead and multiply this all the way across, if I pull my calculator back over, I got 13 times 4 times 25 students times the 1 desk, and then that's all divided by 1 on the bottom. So my final answer then is going to be that I have 1,300 desks. So I could find that answer by using dimensional analysis and crossing out my units. Why don't you go ahead and give this one a try using the conversions between centimeters and getting to kilometers. So pause the video and then check your answer. So hopefully this is the answer that you got. You can check your work as well. Make sure your units all crossed out. But the question was asking how many quarters laid end to end. And so my final answer needs to be in quarters, remembering to write the units down. And quarters is my top unit that I have here. We got one more for you to try. This one is crossing out a few different units. So I'm going to go ahead and get you started on this, but then I would like you to pause the video and try to finish it up on your own. If you think you can do it all on your own, just stop the video right here and go ahead and get started on your own. So it says if you're going 50 miles per hour, so that's telling us what we're starting with. Then it says how many feet per second are you traveling? So we are starting with 50 miles per 1 hour. And I have to get it to being feet per second. I need to either start crossing out my miles units and then go on to hours, or I need to start with hours and go on to miles. So go ahead and pause the video and see if you can figure it out. So if you did your work and you first went from miles to the feet and then took care of your minutes and your seconds, then you should have got the answer like this in your work as you see it. If you went the other way, you would have still got the same answer. You would have just been crossing out the units at different times. So hopefully this was helpful with dimensional analysis, and the best way to get better at it is to keep practicing it. Have a great rest of your day.